Okay, so in this video we're going to be talking about the differences between torque and force and how they affect the conservation of momentum of a system. So, we're treating the dart as its own system, and then we're also going to be treating the dartboard as its own system. So when I throw the dart on the dartboard, the force that my hand uses to throw the dart is going to be the force that the dart hits the board with, and the board applies back on the dart because of Newton's third law. Every action has an equal and opposite reaction. So I throw the dart, and it sticks. So when we're talking about the linear properties and the linear qualities of the dart, we know that momentum is not conserved because there's a net external force on the dart. If there wasn't a net external force, the dart would have went through the board, through the wall, and all the way into the other room. But because the board has a normal force and then applying it back on the dart, it's causing the dart to stop and stick like that. And we know in a system when there's net external forces, its linear momentum is not going to be conserved. However, when we're speaking rotationally, when the dart flew out of my hand, it spun and it hit the board. And there's a torque on it. And we know that when the dart hits the board, its force is applied at 180 degrees. The normal force from the board is applied on this dart at a 180 degree angle. And if we look at the torque equation, T equals RF sine theta, when we plug in 180 for sine of theta, that equals 0, so that's going to cancel out, and our net torque is going to be equal to 0. So when we're speaking in terms of rotations, the torque applied on this dart is 0. So we're actually applying a force on the dart, but we're not applying a torque. So its momentum is conserved rotationally, but not conserved linearly.